Hello guys, welcome to East Coding. In this video, we are going to see the Leetcode problem number 292, Nim Game. Let's get into the problem. So the problem statement is, you are playing the following Nim Game with your friends. Initially, there is a heap of stones on the table. You and your friend will take alternative turns and you take first. On each turn, the person whose turn it will be, it will, on each turn, the person whose turn it is will remove 1 to 3 stones from the heap. The one who removes the last stone is a winner. Given n, the number of stones in the heap, return true if you can win the game. Assume both play optimally, return false if you are not playing. So inside there is a number of stones, and I and my friend will take alternative turns, and I take it first. On each turn, the person turns whose turn is will remove 1 to 3 stones from the heap. So the one remaining last, there is a one to remove the last stone will be the winner. So how can we approach this problem? Let's see. So there will be a n stones, and can the n be 0? So no, it cannot be 0. So what we need to find out, true or false, whether you can win or lose. So yeah, how can we approach this problem? So approach would be, so initially player 1 will play the game starting. So in each move can be defined as removing 1 2 3 stones. So the first step is going to be what will they do? If they are both playing optimally, the first player would remove, if there are 4 stones less than 3, if the first player has stones less than let's see, so less than or equal to 3. So first player has 1 to 3 stones, finally he will be winning. Or else the second player, when second player has 1 to 3 stones, finally the answer will be false since player 2 will be winning. So how can we bring this every time? How can we make player 1 and player 2 both play optimally? So for each stone, what can we do? The player 1 can remove, when there is a 5 stones, the player 1 can remove 1 stone and make player 2 to remove 3 stones, but player 3 will 2 will remove 3 stones, and finally there will be 1 stone left. So player 1 will be winner. So what happens if there are only 4? So in this case, player 1 can remove 1 or 2. So if he removes 1, the player 3 will take 3, and finally player 1 will lose, so false. So how can I approach this problem? If it is only 2 less than 3, less than or equal to 3, then player 1 can win. So if it is more, what can he do? So if there are more, hmm, initially when we consider just up to 6, so when there are 6 stones, the player 1 will, when player 1 removes 3, player 2 will remove 3. So in this case, player 1 loses. So when he removes 1, the player 2 will remove 2, and finally it, so yeah, so when we consider 4 stones, player 1 will remove 1 and player 2 will remove 3, and player 1 loses. When we consider 5 stones, 1, 2, 3, 4, 5. Player 1 can remove 1 and player 2 will remove 3 and finally player 1 remove and finally will return 2. So you can clearly see that the player 1 can win only lose only if n is equal to 4. In all other cases the player 1 will win. So this is the simple logic behind it. So let's try it. So you will return if n is equal to 4, you return false or else true. So let's check for this case. So let's have this case as default value. I mean, all these cases working fine. So let's submit it up. So in this case, they have given for 8, and that is 8. They are going to remove 1, 2, 1, 2, 1, 2. So whenever the n is multiple of 4, return false or else true. Let's check it out. So we'll check with 16. Let's submit it up. Yeah, accepted. And the time constant approaches order of 1 and space complexity approaches order of 1 and approach for this problem is bit very puzzle. So that's all about this problem guys. Thanks for watching this video. Have a great time.